everyone. Welcome to the sixth session of Electromagnetic Theory and Interference course. Today's session, let us see how to solve a given problem in coordinate systems. So, in this question, a point P is given in Cartesian coordinates, that is x, y, z points are given, and the vector in Cartesian coordinates, a vector in terms of ax into x cap plus ay into ay cap is mentioned, and our task is to find the point P, and we have to find the vector A in other two coordinates. So first task is to find the coordinate points in cylindrical and Cartesian. Rho phi is at r, theta and phi, and we have to find the vector also in that same coordinate, and finally we have to evaluate the resultant vector at the point P, okay, in all the three coordinates. So let us start by finding the points in the other two coordinates, then we find the vector. Okay, so we know from the cylindrical coordinate system rho equal to root of x square plus y square. Putting the values of x here, that is minus 2 the whole square plus y plus 6 the whole square, we will get the answer as 4 plus 36, that is root of 40. Whereas the phi angle is given by tan inverse of y by x. So tan inverse of y is x is minus 2. So the answer will be tan inverse of minus 3. If you take tan inverse of the negative value, we will get a negative angle. And what we should do, we have to subtract that angle from, not subtract, we have to add 180 degree to that particular negative angle that we got, and then we have to write the angle in a positive degrees, and z remains the same, that is z equal to 3. Whereas for spherical coordinates, the r value is given as root of x square plus y square plus z square, that is equal to root of minus 2 the whole square plus 6 square plus this 3 square. So the answer that we'll get is root of 49, we will get, that is equal to 7. Whereas tan theta is equal to tan inverse of root of x square plus y square divided by z, that is equal to tan inverse of, already we have computed here as root 40, and we have to substitute the value of 3 here, and we will get this particular angle. So the point in Cartesian is represented as the point in cylindrical coordinate, and this is a point in spherical coordinate system. So the next task is to, as we know, as we have been given the A vector, and we have to substitute the point P values in the A vector to find the resultant vector in Cartesian form. So the vector A at the point P is given by, see, minus y is not y into ax, y means 6 into ax plus x plus z at ay. So x is minus 2, z is 3. So minus 2 plus 3 is 1. So here ay vector only comes here. This is a resultant value, vector value. Okay. Now let us find the vector in cylindrical coordinate system. Finally, we will do it in spherical. Okay. So from the given data relating with the standard vector equation and Cartesian form, we can write ax component is nothing but y. Okay, that is written here. Ay component is x plus z, and az component is not mentioned, so it is 0. So we know the transformation matrix which converts the components a rho f, that is given components ax, ay, az into a rho a phi and az, right? So we have to substitute these values for ax, ay, az, and this is a standard matrix that we have derived in the last sessions. So substituting here, a row turns out to be multiplying this first row with this column, y into cos phi plus x plus z into sin phi. Similarly, a phi is equal to minus y into sin phi plus x plus z into cos phi. Here for a is that, so if we multiply, these terms will turn. Now let us substitute the values of x is equal to rho cos phi, y equal to rho sin phi in the above expression that we got from this matrix relation. So after we will get this resultant vector in cylindrical coordinates. is a rho multiplied with a rho cap plus a phi multiplied with a phi cap. Since a is term not there, that term is not mentioned here. It's 0, right? So substituting x and y in this expression, we get for y it is rho sine phi. So rho cos phi sine phi plus for x is rho cos phi. Okay, so rho cos phi z remains the same. Sine phi is there into a rho cap plus minus y into sine phi. Minus y means so y is rho sine phi. Already one sine phi is there. So it turns out to be minus rho sine square phi plus for x it is rho cos phi plus z into cos phi into a phi cap. So we have already computed the value of rho and phi in previous expression. We are going to substitute. And here are all the terms are in terms of cos phi, sine phi and rho, right? So we have to from this relation tan phi is equal to y by x, we can write the relation of, and rho value we can write the relation of cos phi is x by rho. So x is minus 2 here, rho is root of 40. Sine phi is y by rho, so y is 6 and rho is root of 40. So substituting these, so rho is for rho cos phi sine phi, we will get these values plus again rho cos phi plus z is nothing but the 3 same in Cartesian, and multiply with sine phi, we will arrive this particular result. Similarly do for the second expression. Finally, we will get the vector in cylindrical coordinate. Similarly, we have to do it for spherical coordinates. Take the transformation matrix where we are already aware of ax, ay and az term. Then we are supposed to find the ar, a theta and a phi. So we get multiplying first row with this column y sine theta sine phi plus x plus z sine theta sine phi for AR term. For A theta is the second row multiplied by this column. For A phi it is the third row multiplied by this particular column. So after writing this expression, we have to substitute the relation between x, y, z and r theta phi in spherical coordinates. So x is equal to r sine theta cos phi, y equal to r sine theta sine phi, z is equal to r cos theta. Substitute everything in this above expression. We will arrive this particular vector equation in spherical coordinates. Now our task is to substitute the r value cos phi, sine phi, cos theta, sine theta, tan theta, everything values in this expression that we got in previous step. So we already know what is r. Tan phi just now we saw it is y by x 6 by minus 2. So from that we have just computed cos phi sin phi in the previous step. Now for tan theta it is rho by z, right? So if I want to write cos theta, is it z by r? Z is nothing but 3, r is 7. And sin theta is rho by r. Rho is root of 40 and divided by 7. Substitute these values in this expression for r sin theta cos phi sin phi, everything if we substitute we will end up we will get this vector equation in spherical coordinates. Our last step is to evaluate point vector a at the corresponding points in all the coordinate system. So already we found for Cartesian. Now for Cartesian we substituted the values, right? Now we have computed the vectors and all the coordinates apart from the one given in Cartesian system in our given expression. We substituted the points for x, y, z and got this expression. Similarly for a cylindrical and spherical we have done. The interesting point to note that is the magnitude of A in all the three coordinate system for the is going to be the same. Okay, you can take the magnitude and try it. That is, here it is going to be root of 6 square plus 1 square. Here it is root of this particular term, the whole square, plus this particular term, the whole square, will give me the answer the same 6.083. Similarly for the spherical also. Happy learning. Thank you for watching the video.